Hello, today I am going to saying about the priority search tree. Based on the name, we can identify that based on the priority which we are giving to the key values, based on that only we are going to inserting the trees. So just check here. Priority trees are mostly used for storing two-dimensional values. It is also one of the data structure actually. It is used for the storing of two-dimensional values. So two-dimensional values means it will be in the form of x comma y coordinates. So in x comma y coordinates we are going to store in the values. Here priority search tree will follows binary search tree and heap properties. So binary search tree means for the root in a tree, left half, that means left subtree should have all the less values, that means it should consist of the values less than the root, and in the right subtree all the values should be greater than the root. It will comes under the binary search tree. So just comes to the heap properties. Heap properties means it can able to either follows min heap or max heap. So in min heap means its root should be minimum value and remaining all children should be greater than that root. So if it is a max heap means its root should be maximum value and all the children should be less than the root value. So here I have told that two-dimensional values it is going to store. In that it is going to store it in the one is a priority order by the priority and next one is order by key value. And here in the next slide, this is the procedure for construction of the priority search tree. Just check these 6 points. First we need to have a set of points. For that set of points we are going to represent it as a yes. So first point is if S is empty we need to represent it as a null. Second point, we need to find the p value. P value means in y coordinate wherever we will find the highest value, that is our p. So after that we will set it as a root also. So third point is we need to find the s minus p. In the fourth point, if s minus p is empty then we need to return p. At fifth point we need to find the x of p. That means we need to divide the points present in the s minus p into two equal halves and then we need to find the median for that. Whatever the median we will get, that is our x of p. So for the remaining steps is we need to find the same for left half of the tree and right half of the tree. Just check it with an example. See here, I am going to constructing the priority search tree here. For this construction, I have already took some points here. These points are 25, 35. So 50, 10. So like this, I have took nearly 8 points. I am representing them each by A, B, C, D for easy identification. So these are the points whatever I had took here from A to H. So first step I am going to sorting the x coordinates. That means based on the x coordinates I am going to sorting these values. So what is the smallest one? It is a 5, 45 and second one is 25, 35. Like this I have sorted all the values. This is the first step. Now for 2D visualization I have took a this is the x coordinate and that is a y coordinate. So here what I am mentioning, I have took 5, 20, 30 like this, like you can think it as a graph representation also. Simply I am representing this first value is 25, 35. It is in between like this 20 and 30. It is 25 and here what I need to get 35. So like this I am mentioning the A point. Next is 50, 10 for B. This is the 50 and it is the 10. So like this I have mentioned all the points here. Next one is 80, 15 here. 85, 15. 85 here and then 15 here. Next 90, 5. 90 here, and then 5 it will comes here only. So these are the values, or these are the x coordinate, and these are the y coordinate. Next step is just come for the construction of the priority search tree. So I have represented, that means I have mentioned all the S points in the sorted order. So after sorting order, just check for the first step. If S is empty, return null. See, we are having all the values in S, so our S is not empty. So first step, it is a false. Next, I am going for the second step. Find P with the highest value for y coordinate from S. See, we need to find the P value. How we need to find it? Just go and check wherever we will find highest y coordinate, that is our P. See, first is 45, next 35, 40, 10, 75, 65, then 15 and 5. So in this y coordinate, which one is highest? 75 is highest. So I have rounded it, and that is our P value. So 75 means easy representation, just go here. 75 means it is our G value. That means just for a representation we are going to giving the small alphabets, no? It is a G. So see here, I have written it as a G only. So next thing is, it is also completed. From S we have found the P. Now set P as a root. That means our G is a root here. Our G is root for us. So next thing is, that is the third step is find S minus P. Remove P from S. P means 60, 75 is a value. So we need to remove this value from S. So see here, for easy representation I have mentioned here. From this place I have removed the 60, 75. So just check. I have written all the remaining values. Now what I need to do? Just check if S minus P is empty, then return P. Now we need to check if S minus P is empty, we need to write P as it is. But we are having, again some values are there in the X. So S minus P. Now we need to find the X of P such that X divides the point in S minus P into two equal halves. So how we need to find the X of P means, first we need to divide these all values into two equal halves. How we are going to dividing it? How many we are having? 5, 45, 25, 35, 35, 40, like this 50, 10, 80, 65, 85, 15, 90, 5. Totally 1, 2, 3, 4, 5, 6, 7. We are having 7 values. You know how to divide it. That means 7 by 5. If you took it as 7 by 2, how much we will get? Nearly 3.5 it will be. 7 by 2 means 3.5. So what I am taking here? 3.5 means for one side, that means for one half I am taking 3 values, and for second half I am taking nearly 4 values. So this is it will be considered like a left half and it is a right half. So one is left half and another one is the right half here. So 5, 45, 25, 35, 35 and 40. These are the left half, and remaining 5, 10, 80, 65, 85, 15, 90 and 5 are the right half. So now what I need to do? I need to find the X minus P, X of P. So how I need to find this X of P means, I need to find the median from this left half and from the right half. So here for the left half I am taking 35 and from right half I am taking 50. So 35 plus 50 is 85 by 2. I am going to finding the median. No, 85 by 2 means we will get 42.5. So I won't take the fraction value, I am taking the integer value. So 0.5 is there, no? So I am moving forward and taking the 43 as a median. So for this x of p, so simply I have written it is like a x of g. G is our root, no? For that 43 is the median value. See, for understanding I have written here S of p is having 7 points. So I will take 3 on right side. And sorry, here I have mentioned like a 3 on left side and 4 on right side. So now again we need to find the median for 35 and 40. So if I combine them, simply I will get 85 by 2. For that I have written it as 43. So now what has completed? Only for one we have completed the left. That means for root only we have find out the x of p. So recursively for above all, that means for the left half and for the right half, we need to find the priority search tree. Based on that we need to construct the tree. So just move here. For the left half, in our left half what and all we are having? 5, 45, 25, 35 and 35, 40. So those are in the left half. So here I have took that left half. In S place I have take 5, 45, 25, 35 and remaining one. Now again the second step is what I need to find. I need to check for the I need to find the p value. How to find our p value means whatever the highest value for y coordinate, I need to set it as a p. So here what I am having, 45 is the highest value. If check here means 35 and 40, these are less than 45. So I am taking this as a 5, 45 is my p value. And there is a second step, that means the next step what we need to do, s minus p. S minus p means we need to remove this p from the s. Remaining are 25, 35. So 35, 40. Now what I need to do? Again my s minus p is not empty. So I need to divide it into 2 equal halves. See here, in our fourth step what they have mentioned, if s minus p is empty, then we need to return p. But our s minus p is not empty, no? So we need to find the x of p. That means how to find this x of p means first we need to divide the element, that means the values in the s minus p into 2 equal halves. 2 equal half means these are only 2 values. So I am taking 25, 35 one side and 35, 40 one side. So you know how to find the median means 25 for x coordinate I am finding the median 25 and 35. What is the value here? 60. Then 60 by 2 is 30 only. So here E is the left subchild of G. So if you consider here, I am going to mention it like, so E is the left subchild of, so I will simply represent it as L. L means left child. So E is left child of G. So then here I am having 25, 35 and I have found the median for this. So now again what I am having remaining 5, 45 I have removed. Remaining whatever the values are presented in the S minus P, again I need to find for that. See 25, 35 is on left side and 35, 40 is on right side. So again for these two I need to construct the priority search tree. Simply see here on left side I took it as 25, 35. So there is only one child, that means there is only one value. So for P also I am considering the same only. I am not changing anything because only one value is there. For P same will be coming 25, 35. Now S minus P I am finding. So I have removed this P from S. It is empty. Now I got the empty. Empty means what I need to do? Just see here I need to write the P itself. Whatever the P will be there, say, check in the fourth step. If S minus P is empty, I need to return P only. So I am going to write it as same only. I need to return A itself. That means A is the left child of E. So A is the left child of E here. Now what I need to do, I need to find the remaining right child. See here 35, 40 is on the right side. For that also I am finding the same P is same value only, because only one value is there. So I am taking the same. So S minus P is empty. I am returning the F itself. Right? F is a right child of E. See here, F is the right child of E. So here G is a root. For this root, E is left child, and for this E, A is left child and F is right child. Now just go for the right side of the root. See here, all left I have already completed. That means we have already completed. So for this right side, from 50, 10 to 90, 5, I am having 4 values. For these 4 values, I need to do the same process. See, till here I have already completed the left child, and from here I am starting the right. See, I have written all the values here. First I am going to finding the largest of y coordinate, because it is our P. Same here, 10, 65, 15 and 5 are there. 65 is the large y coordinate. So I am taking 80, 65 as the P value. Now I am removing this from S. If I remove it, what and all are there? 50, 10, 85, 15, 90, 5 are there. Now if S minus P is empty, then only I need to write P. Otherwise, I need to find the X of P. No. For this, what I need to do, I need to divide these values in X minus P into 2 equal halves. But here I am having 3 values. So I am taking 1 at one side and remaining 2 on the second side. That means on the another side. This is the left side and this is the right side. So see here, X of P equals to X of H. For this X of H, I am going to find it. I need to find the median here. It is a 50, and for this X coordinate I am taking 50 plus 85 by 2. Finally what I have got, 68 is a median for this. Now I have divided, no, 50, 10 one side and 85, 15 one side. So for this left side, I am going to finding this. That means I am going to constructing the priority search tree. So same 50, 10 I am taking. That is only one value I am having. So P is also same. So if I find S minus P, it is a empty only. So I am going to returning the same. B as same I am going to returning. So this is the left child actually. So left child for what? For H. So for G, H is the right child, and for that H, B is the left child actually. So see here, for G, H is the right child. For this H, B is the left child. So B is the left child. So now for here, B has been completed. It is a left child. Now again I am going to finding for this 85, 15, 90, 5. These are on the right side now. So what I am going to do, this is my S values. These are the same as S only. Now for P, 15 is having the highest y coordinate. So P is my 85, 15. Now what I am going to do, S minus P represents 90, 5, because 85, 15 I have removed and only one value it's left. So if only one value is left in the S minus P, now what I need to take as a median for C is, I am tightly taking this 85 only, because only one value, that is 90, 5 only has left. So what I need to do, for X of P, I need to take 85 as the median for this X of C. So I have written here, there is only one point left, that is 90, 5. So I am taking X of P as a 85 only. So next, at last, just go with the graph I will show you. So in the graph, D is the right child and N means it is a null, because there the points are 90 comma 5. So for 85, 90 is greater than 85. So I am moving this 90 to the right side of the 85. So here just check here. So here I have mentioned G is the root and E is the left child. At the same time, H is the right child and E is the left child of E, and F is the right child of E. And for H, B is left child and C is right child. And here D is the right child and here just simply null is a left child. So you already know that. If you check the balancing factor also, for D it is 0 because it is at the end node, no, so there will be 0. And for C it is like and right side, that means right side is a -1 and for the left side it is a 0. It means left subtree minus right subtree, no, 0 minus 1 is -1. And for B it will be 0, and for H it will be 1 minus 2 are there. One is C is there, sorry, C is there and another one is D. So 1 minus 2 is -1. So just that means there won't be any proper condition to satisfy the height balancing tree, because it just follows the binary search tree property. If you want, you can able to compare it, otherwise no need to compare or worry about it. So just check for the median values also. See, I'm just taking the median values. If you go with the G value, means for the G is the root, no, for this G what is the median? It is a 43 is the median. So next for E it is a 30 is the median. So same things I have mentioned here. See, 43, 30 is less than 43. So what it represents means, so here whatever the elements less than 43 are on the left side of the root and greater than 43 are on the right side of the root. So you can able to easily compare or you can able to find the proper priority search tree based on the median values also. So just check here in the 2D visualization, I have mentioned that G is the root and E is the left child and H is the right child. So whatever the horizontal vertical lines I have mentioned, these are all the median values. So the median values. So this is the priority search tree. So if you have any doubts, please comment in the comment section. Thank you for watching my video.